And we are live now. This is the first time for quite a while that I'm going live. But let's see if everything is also working. This looks good. So looks like everything is working now. Okay, everyone, welcome to my stream for today. I haven't streamed for quite a while, so it's great to be live again. And today we'll do something again with MCP server programming. Originally, I thought I'd do this in Elixir, but no, I'll not. Will not do, simply because we want to experiment and we need to get quick results. And there is no ready-to-use Elixir library for quickly building an MCP server in the easiest way. So we will do this experiment in Python, but that shouldn't be really the game changer here. But what will we do today? So let's quickly look into the idea we want to explore. So, so when we look here at the drawing board first, what we want to do is something like having, let's change the color and structure. So let's say we're starting here with our coding agent. Usually this is Claude Code, at least for me. It is currently the tool of choice here. So let's say we start here with Claude Code. And what we want to do usually is we want to provide Claude Code something like a context. So we need some kind of the model context. And in the model context, we need a lot of things. We need, for example, documentation. Usually we have an agents MD file or Claude MD file. We have several other documentation that we want to use. We might have custom prompts, we might have sub-agents, all the stuff that goes in there. And this is actually a quite nice approach to have this somehow ready. The problem that we ran recently into together with some other engineers is that the problem is actually you cannot reuse that really well. There is some issues with doing that. You can commit your agents MS or MD file or your Claude MD file to Git. That's working. But what you cannot do is really seriously check every specification that you're writing for every single task into your Git repository. You can probably try this, but it's probably not really working out. So this seems to be quite difficult to do. And so we want to provide the agent a model context, but managing this model context is quite difficult. So this brings up a very simple question. Why can't we apply what we do in programming as well? Why can't we have something like, let's say something like a package manager. And this package manager actually contributes to our model context. So that's the rough high-level idea. Let's say we want to build up the model context, and on one hand, Claude Code with prompts, with all the stuff that is provided by Claude Code, is building up this model context. And on the other hand, we could have a package manager that could also add something to the model context. The obvious question is, how do we actually add the package manager stuff to the model context? And the obvious answer to that is we are using the model context protocol, of course. Keeps us the question, what goes into the package manager here? So let's quickly think about it. What we need here is probably something like documentation. So when I'm talking about documentation here, what I really mean is agent-specific documentation. So agent-specific documentation means something like your coding standards, your product definition or documentation, actually. What are you building? That's something the agent needs to know. What is your tech stack, for example? Those kind of things. But also for concrete task that you want to work on, you need some specification for the task, obviously. So this is also something that needs to go into the documentation here. This is not a normal documentation. It is way more documentation. And one of the problems is sharing this documentation within the team and using it across different applications. So let's say you're working in a company with a microservices architecture. You have 10 services that you own, and now you want to update your documentation. Do you create a pull request in every single repository? Is this what you want to do? I don't think so. So there is actually some problem with actually managing this kind of documentation, especially in a reusable way and in a way that works for the whole team. And what you also want to put here is probably tooling. And when I talk about tooling here, there's two kinds of tooling I have in mind. So one is actually the obvious MCP stuff, but you don't want to put MCP server everywhere and so on. You want to somehow manage this. If you want to work in a team, what you really want to do is something like npm install, and then you have all the MCP servers ready that you want to use in your and all the tooling ready. The other type of tooling that you want to use and in your the other type of tooling that you want to use within your application or within your development environment is scripts or MCP server. So some kind of tooling that is doing something. This can be a simple Python script. And yeah, I saw already that the tooling box is covered. I moved it here already. Thanks for mentioning. Yeah, so as I said, the type of tooling that you want here is usually something like scripts, probably scripts that are generated by the LLM on the fly while you're working on it, but you maybe want to share them. This is very useful. So this is basically the idea. So what if we could build something like a package manager? And let's see, I've typed in here. So this is an experiment. So this is not something we want to bring to production tomorrow, but something that we want to experiment with today. Can we make this somehow work? Obviously, we can. MCP allows us to do that. We will see this in a second. But there's one problem, and that's why I'm doing this experiment mainly. And that's LLMs are good at using tools, but they are even better at using tools that they know quite well because they are trained with it. So, for example, files in your file system work much better or can work much better than things that are provided via the MCP. So we have seen that in some examples that MCP works okay, and in some other examples already that MCP doesn't work that well all the time. So MCP is not necessarily the best way to go, simply because the models are just not knowledgeable enough about MCP. They know bash scripts, they know files, but they don't really know what this model context, protocol, tooling, blah, blah, blah stuff should be. I would expect that this will change over time, but at the moment, the models are not that good at it. So I would like to see, is this a way to go with? Or if we would build something like this package manager, should we maybe just manage files in the end? So let's see. As I said, just a theoretical experiment. Let's see how this is going. The question, of course, first is how can we build something like that using the model context protocol? So if we are jumping here into the specification of the model context protocol, We've gone through that already in another stream, but it's still the same concept, although the version has been upgraded in the meantime. It's still the same concept. We have a transport, which can be stdio, which can be HTTP. And through that transport, a JSON RPC-based protocol is used. So there are requests as JSON requests and JSON responses. So a request-response pattern. And there are notifications. So both the client and the server can send notifications. And at the end, the transport provides a stream in each direction from the client to the server and the other way around, so that each of them can send requests, response, and notifications. So very straightforward protocol. It's mainly derived from the principles behind the language server protocol that is used by modern IDEs like VS Code. So it is the same concept. The specification contains most of the relevant parts, and the ones we want to look into today is mainly prompts and resources. So what are prompts? I think this is actually already a very well description of what prompts do in the end. If you have, for example, Claude Code or something like that, you might have the possibility of using the / commands. And what prompts do is basically they, in the best case, add / commands. But those / commands are provided by an MCP server. So you add an MCP server to your coding agent, and what you get is some additional / commands from it. And yeah, the concept behind that is quite simple. You have to declare the support for prompts in your initialization request or response as a server, and then the protocol itself is rather simple. There is a prompts list command or request, which allows you to show a list or request the list of available prompts. And this, of course, is then a list or an array here in the JSON response, which has then several tools. Tools have names, they have titles, descriptions, and optional arguments. And when we are looking at the prompt get, this is the second thing that we have. It is basically, the prompt get request takes the name and the arguments that have been defined in the prompts list. That's it. And then you get a response, message, role user, type text, and then you have some content here. There's also a notification if this list changes. We will not do anything about that today. That's maybe for another time. So basically what we have is we have a prompt. It has a name, title, description, and arguments. And we have prompt messages, which have a role and a content. And they can also, of course, be the role assistant. They have some kind of a content where content actually means text. And usually the text is probably code or markdown, whatever your prompt is. That's roughly it. Okay, it also supports images and audio content. Okay, and embedded resources. That's nice. Embedded resources is probably something, I don't know if we will do that today, but it's something that we might look into as well. But we will start with the prompts first. So the second thing is the resources. I just want to, I don't know if we will really manage to do that today, but let's have a quick look into that. So what is the resources? Resources is basically what you get by adding things. So a file resource would be something like a file that you can add here. Or it could be a GitHub repository or whatever. The idea is, the implementation of the agent usually handles them differently. I actually haven't played around with Claude Code how it handles this with resources. So this is also something we need to figure out when we implement this. But basically the concept is again the same. We declare the resources capabilities. And there are two options. So the list can change, or the client can subscribe to notifications of changes of individual resources. So the client can subscribe to a specific resource then, which is fine. We will not do that today with subscriptions and notifications, but at least good to know. And the messages are again the same. We list the resources that are available and then send back a list. And then there is reading resources available, so we can resource read. Okay, there's also something, a resource template, which is which allows us to use, this is nice. So we can use resource templates with URI templates that allow us to, for example, have a set of resources where you can throw in an ID or a name or something like that, which is quite nice. Yeah, the mentioned notifications and subscriptions, some message flow, the data types again. So we'll maybe make it to the resources, but let's see. If not today, we'll do this in a follow-up stream. Here's some examples. Nevertheless, we will do this as well. So the basic idea is that we have prompts that we can reuse, and that we have resources like documentation as Markdown or something like that, that we can actually request. And all of that provided via the model context protocol. Let's figure out what type of thing we want to use here. So there is something called the Agent OS, which is a nice open source project. And Agent OS is a system for spec-driven agentic development. This is exactly the type of thing I want to enable here. And I looked into it. I haven't tried it yet, but I looked into it, and it looks a lot like it is built for, I installed it into my development environment to make it work and use it, but it's not really designed for development in a team. Although teams are even mentioned here in the description, but it's not very well handled. At least it doesn't look to me that it does this very well. But we will try to use this because what it has is some very nice things. It comes, for example, here with the standards and provides some best practices, template, and so on. So basically, the structure and all the stuff that comes from the Agent OS is quite nice as a content, from a content perspective, but the setup is not really something I like a lot. And it's maybe also not useful for every tech stack because it's very specific. What's quite interesting is the commands section here. So what we see here is we have, for example, the analyze product command here. And what those commands in Agent OS are doing is they are becoming prompts. The way this works is you put this in a specific directory in your project, and then Claude Code will automatically make this a prompt. That's nice, but very Claude Code specific, and doesn't work in the same shared way as I wanted to do that. So what we can see here is it refers actually to some file. In our case, it would probably refer to some, let's say, resource instead. But it refers actually to some file that it should use to analyze the product. And if we look into that file, let's see where we can find that one. Instructions core analyze product MD. So here is a markdown file with some further instructions like perform deep code base analysis of the current code base to understand current state before documentation purpose. Some interesting information. Step 2, gather product context. Context question based on my analysis of your code base. Can you see you're building I can see you're building blah, blah, blah. To proper set up agent OS, I need to understand product vision, current state, roadmap, team preferences, and so on and so on. So as you can see, this is actually a template which is which gives the agent instructions for an interactive flow. So we are asking the agent to ask the user for additional information. And then the user can enter this additional information, and then the agent can continue doing that. The result of that, I don't know if this is written somewhere here. I guess it is. Current development. Successfully installed. Yeah, maybe not. It doesn't matter. So the result of that will actually be some documentation about the product. So this guides the agent actually to ask you the right questions and do the right analysis on the code base to finally come up with a proper description of your product. So the next time that you can that you are doing something is, for example, you want to plan the product, whatever the planning means, and there's also the same principle. You have a command here, which is basically a / command, like a prompt, and it executes the planned product script here. Basically, I like the term script here, as it is a script for an agent, not a human or not a computer. But what we see is the same principle here. But what's the point of this is it will guide again the agent to plan the product, and it will therefore contain the previous description. For example, here the pre-flight and other data that will be generated through the analysis process and so on. It will use that to create a proper description or a proper planning based on some templates and so on and so on. So this is quite some interesting stuff. And what we will do is actually we will use these commands and also the these instructions here to build up our testing set, or to use this as a testing setup for our package manager stuff. So which brings us to the last bit for today that we need to take into consideration here. And that's the Python SDK. So the Python SDK is quite a nice one because it's well maintained and one of the first that have been developed. You can look here into the README. It's quite extensive. It works quite straight out of the box. You just use the UV package manager to initialize a new project, and then you do kind of things. I've prepared actually a project already. So let's just jump over to the project and wait. So let's install UV. No, let's install the MCP library here, the SDK, and then we are ready to run. We can already run the UV command. Let's do that. It just tells us actually some help information, of course, because we're not really running something, but we can use here the def command to run the MCP server in development mode, which is probably what we will do soon. Let's quickly jump back to get a little example. So here's a hello world, basically, that looks quite nice. Let's just do the obvious and copy it here in. And then let's try this once again. So we can use actually the def and then pass in the Python script that we have just created. If we run this, we will see the MCP server is starting. And this is quite some interesting thing to keep in mind. So what's happening here is that the MCP server is started, but not just the MCP server is started. So in this case, the MCP server just uses stdio, which is the simplest approach that we can do. So that's quite nice to try things out, at least. And what you can see here is actually it's starting the MCP inspector. So the MCP inspector is a nice tool that you can use for dealing with or for developing MCP servers. So let's jump into the inspector. So it's a web application that opens up, and the nice thing is that the Python SDK by default installs this. So this is one of the reasons why we do this experiment in Python, because you get everything already with the SDK being installed in a very nice preset way. So this is from a previous session cached, so this is not really correct. I want to this is coming via stdio. So if you run the connect, then we see it's connected now, which is not a big deal because stdio is just running. And we see that there is already an initialize request. This is actually what happens on the beginning of running an MCP connection to an MCP server. The client calls the or makes an initialize request, and the server responds with its capabilities. So for example, it supports prompts, list changes false, it supports resources without changes in subscriptions, and it supports tools here. There's a server info, in this case it's called demo and has a version of 1.13.1, which is interesting. But let's quickly jump into some of them. So if we go to the tools, we can call the list tools. We have an add tool, so we can probably type in some numbers here, and it tells us the output schema. So if you run the tool, then no big surprise, the result is 5. So it looks like it works as expected. But we are not interested in tools, we are interested in prompts. So let's see what we have here. We can call the list prompts. We have a greet user prompt, so we can enter a name here. And we can enter a style. Okay, whatever a style means. Let's have a quick look into the code about that. So we have seen so this is actually how it works in the end. So we create an MCP server with this fast MCP object. This is probably derived from the fast API library, which has a very similar approach. Let me quickly. So we have fast API, fast MCP here being used. It has a demo name, so this is probably what we have seen earlier. We want to call ours here MCPKG for MCP package. Very innovative name, of course. And then we have the tool being declared here. So we use MCP tool on a function or on a method in Python to declare this method as a tool. So here is exactly the add tool that we have seen earlier that gets an integer or 2 integers as an input and returns the sum of it. We also see the resource here. We'll come to that later. We also see the prompt here. So this is how we declared, or how this prompt is declared. We have a greet user. So the greet user is having styles, friendly, formal, and casual. Ah, interesting. And there is a name passed in. So let's see what happens if we use the formal style. No, formal sounds good. We are in Germany. So let's see what happens if we get the prompt. So there is a message, there's some content being returned. Please write a formal professional greeting for someone named Jan. So that's interesting. Oh, well, not much surprising when you look at the code, but that's basically what our prompt does here. So this would be then something that the MCP, but Claude Code would actually get. We can try this also out. Let's give this a try. MCP. So what we can do here is we can add with the scope of this project stdio, then uv main. As you can see here, it modified the .mcp file in this directory. So if mcp.json file. So if we look into that file, you see actually here the command is uv, or no, the MCP server is called uv, which is an ugly name, but works for now. It has a command, it has an argument, there is a type of transport and no environment variable, so this might be fine. Let's run Claude and use this MCP server, and it failed. Oh no, why did it fail? UV failed. Enter to view the... yeah, of course, I added the wrong thing here. Now I realize this. Let's just remove the MCP JSON here and add the correct command. So uv run is not correct. We also wanted to add the... No, that's... once again. So the correct command was uv MCP dev. That's it. That's the one we are looking for. Run MCP dev, and now the main py. Yeah, that's the one we are looking for. But we are not looking for running it in the dev version. That's an interesting command. Yeah, that's the one. So let's copy this one and use this correct command. So once again, run Claude. Again, it failed. This one. Really well. So, okay. It is connected. List prompt gives us a prompt. Interesting. So if this works, the question is, if this works, why doesn't the other work? That? Let's quickly look in the documentation. Because for some reason the inspector works, but not our. The So I think I understand this. So when we go back, I think the Sentry example here is quite good. So we add here the MCP server with transport HTTP, and then we pass in the URL for that HTTP-based MCP server, and we give it a name. So if we look for Claude MCP add --help, I hope this would give us something. Here we are. So Claude MCP add takes some options like transport stdio and then a name and a command or URL. What we have provided so far is we provided UV here, and UV was interpreted as the name, which is I was already confused about that, and it's obviously not correct. So we want to say this is called MCPKG. And this is the command then. So this should now work. Let's double check the file. Okay. Let's do this once again. And this server we want to use. And it doesn't fail anymore. That's great. So now we can MCPKG greet our user. And we need the arguments Jan and formal. So now, good day, Jan. I trust this message finds you well. Please let me know how I may be of assistance to you today. That sounds good. Okay. Why can't I see what is there? Interesting. So, this is nice. We have used our... I can't see the details of the prompt. That's interesting. Okay, it doesn't matter. So we now know how to test the prompt in the inspector. We now know how to interact with it, and we can see that this prompt is actually working. So using a prompt via MCP is pretty straightforward, isn't it? We just can use it. And This works already much better than I expected this. I did a little bit of research, but not that much this time. And so I'm now a little bit surprised about how well this works. So basically what we already can do is with our prompt, we can already say, so Claude Code will already make this a slash command prefixed with our MCP server, which is exactly the thing we want. So this is quite cool. I think that's also exactly what we want to have, because now when we look into the agent OS, what we could do is basically we could take all these commands here and make them all prompts. We could just have a directory somewhere called commands, and in this directory, or prompts, or however we want to call them, and within that directory, we can just throw all those into and let it work. The problem still is, if we go back to the okay, to this first one here, if we go back to it, what we see is actually that it just refers to the instructions in the corresponding instructions file, which totally makes sense. But for us, this instructions file is, of course, not a file. We want to make it a resource. As we have seen earlier, a resource is something like this. I haven't tried this out, how resources work in Claude Code, but I think we will figure this out, because what we can see here now in the code base is that there is already a dynamic greeting resource. So the question is, what is this greeting resource? The greeting resource is defined by some URL starting with greeting. That's interesting. And it just inserts some string here. So the resource even takes a parameter in. So we have a URL with a parameter, and then this parameter is passed like with an HTTP-based API that you could define with fast API or so, instead of a get with a parameter in the URL. We have a resource here with a parameter and a custom URL type here. That's basically it. And we return something where we pass this name into, which is quite simple. So my naive assumption would be that I could just say MC. No, it doesn't work like that. I know, greeting. No, that's not how it works. So let's tell me greeting. See what it does. It worked. So we can just use the greeting resource here. Very, very nice. It looks quite wonderful. So let's combine the two. That sounds like a cool idea. Let's combine the two. And let's say we have get formal greeting. We're playing around with this code base a little bit, that's all. So nothing really useful we are doing here. We're just playing around. So let's see, can we just do formal and do another one? That was wrong. That was do another one. That is the friendly greeting, which comes which is the casual. So it's an interesting experiment. So now this the styles, which in this case is casual. So let's just take this one here and replace it with that. So now to do instead is to say follow the greeting file name. Just so we should, let's see if this works. Like that. Let's exit it. And what we can do first is actually we can just run this with UV-dep. Let's try this out first. Just that we are on the safe side, that we know it works. We have the prompts listed, greet user, we enter the name here, and we enter a style. And then we get a prompt and it tells us greeting formal Jan. That's how it works. That's correct. Let's give Claude a try as well. So Claude will run. And what we want to do is now MCP greet user Jan formal. Yeah. Done. That's quite interesting. I'm pretty surprised that it works just like that. And to me, it looks a lot like at least Claude Code is able to deal with exactly this type of resource and prompt stuff quite well. Wow. I'm pretty much surprised of it, which is great. Great outcome so far. So let's go back to the agents OS. So what this would basically mean is that we put those files here. And I know if you install it properly and so on, it will do some other stuff. But that's not really the exercise we want to do here. You know? That's not really what we are looking for. We're looking here for some very dumb stuff going on. Let's start with the analyze product. So we will just hard code it now. Now let's just copy the raw file. So the tool we don't need actually. What we do instead is we will an MCP prompt. But doesn't get any parameters. It will just return string. Just some which is of course not this one. To to say returns a string. Return. So now my Python ends actually. Is there some multi string that I get to stuff? Triple quotes. Okay. If it's that simple, let's give it a try. What do we want to call that actually? I think it is not a greeting, obviously. It is instructions. Why not just calling it instructions? Instruction call analyze product. So the next thing we need is MCP resource. And that MCP resource is for the URL instructions. I think we can actually leave the MD out. Makes everything a little bit nicer. So we can give them a name. It's returning a string again. Turn next. Now the That's actually with some header. Let's see what happens with this header. I see that's not what we do now is that we file and let's call it the this file gets all the content. I think that works better. So that's to turn MCP KG analyze product. Yeah, let's delegate this to AI. That's a lousy task. Nothing I want to do really. Ah, yes, please just do. Here we go. So now what we can do is we can run Claude once again. Because it returns all the things we want. So I can now run the analyze product prompt. And here I see already the first problem. That's not how I want it. But let's see if it works. So analyze product. I'll analyze the code base and install agentOS according to the instructions. Let me start by reading the instruction file to understand what needs to be done. Oh no, the instruction file failed. And I see why. So, first problem, we called it instruction, but not here. I think we also need to get rid of this. because it doesn't make much sense in the context of our setup. And we want the analyze product prompt. I think we will also remove that one in favor of this. We are already working. I know we wanted to make it work, but it is obvious. This is the read instructions. Let's give it another try. So Claude, we want to run the analyze. No, we want to run the analyze. Oh, what the KG analyze product. Once again. Let me start by reading the instructions and understand the current state of the project. Oh, now it worked. It read the instructions. To go all the way down. There's more there's more inside. Damn. So things will now fail because we didn't add everything. There is also meta instructions. Oh. Of course there is. Yes, I want to run UV3. So what came out? Based on my analysis of your code base, I can see you're building an MCP server project. Top. Classes in C++. I think classes in C++ are the same as classes as everywhere else. So what exactly... actually, this is not about C++. We are doing Python here right now, and I also haven't written any C++ in my life. I think just a few lines of C, but not C++. So I think you have to find someone else to explain you what C++ classes are and what they are doing. Good luck with that. So, code-based analysis summary, tech stack, Python 3, package manager UV, blah, 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 current implementation. Good luck. Basic MCP server setup with fast MCP, prompt, resource handler for instruction files, MCP configuration, instruction system with analyze product MD. Very nice. It did a proper analysis of our stuff. I'm a little bit surprised that it didn't ask me anything, because I expected it to ask questions, actually. Tell me this, tell me that. Here. It ends with it. Okay. To properly set up AgentOS, I need to understand product vision. What problem does this MCP server solve? Who are the target users? Current state. Are there features I should know about that aren't obvious from the code. What's the purpose of instruction system you've built? Roadmap. What MCP capabilities are you planning to add next? Any additional prompts, resources, or tools? Team preference. Any specific coding standards or MCP patterns you want to follow? Woo. Now we have to ask. So, the product vision is to create a package manager for instructions and specifications that should be added to the context of the coding agent. The packages are that to the coding agent via MCP. So that's the more or less nice vision. Interesting. Now it's using some stuff to create a product vision, which is quite interesting and maybe something interesting to understand what to do with it. But let it go. It creates an overview MD. Okay, let it run. We are vibe coding now. Tech stack. Okay, we are not fully vibe coding, to be honest. I'm not allowing, I'm not in a YOLO mode. So the real vibe coders are also more risk affine. It's creating a lot of files, actually. Doing a lot of cool stuff. So we see already that there is a couple of files being created. For example, we have an overview MD. So if we look into the overview MD, we see that MCPKG instruction package manager for coding agents, product vision, target users, core problem. Coding agents often need access to specific instructions, templates, and workflows to perform complex tasks effectively. Currently, there is no standardized way to package, distribute, and manage these instruction sets, leading to duplication of instruction creation across projects, lack of version control for instruction sets, difficulty sharing proven workflows between teams, no dependency management for instruction packages. Yes, exactly. That's why we are trying this out. Solution: MCPKG provides a package management system specifically for coding agent instructions delivered through MCP servers, enabling packaging, bundle, instruction template. Key value. Key value proposition. Oh, standardized instruction packaging, seamless agent integration, collaborative development, version management. I never told it about version management, but I like it. Dependency resolution. Yes, that's obviously also what a package manager should do and what happens here as well, probably. So interesting. It looks like I'm tired of pressing OK. Let's just allow it to do everything. But it's, yeah, it added, like usual, things that I didn't tell it, but in this case, that was not a bad idea. Okay, it even upgrades the files. Just successfully installed. Well, I didn't answer all the other questions. Okay, I should have done. Your code base is now AgentOS enabled. I don't like the name AgentOS, but thanks a lot. I think that was actually a rather quick stream today because it went successful much faster than expected, and the outcome is surprisingly good. So I think this is really working out. Instead of putting everything as files in your project, putting them into an MCP server, the prompts and the resources, that works quite well. And this Python SDK made this quite nice to experiment. So if you ever have the situation that you want to try something out with MCP server and a coding agent to figure out if this works, just run the Python SDK with a little script to give it a try. Very nice way to prototype something like that. So that was it for today. I think I will do a next stream next Monday. So at least that's the plan for the rest of the year, to do a stream on every Monday evening, Central European time. And if you enjoyed the stream and you want to do some additional hacking or watch some further hacking next time, then come back and join the stream next week.